Welcome everyone. Today what we're going to do is to find the percent composition of elements within a compound. The percentage of each element in a compound will be determined by mass, and what you're going to see is that it can be determined from the actual formula of the compound or by the experimental mass analysis of the compound. This video we're going to show how, given a formula, how you can find the percent composition, which is also known as mass percent. It goes by either name. Now, sometimes at the end when you check your work, you're going to see that the percentages may not always total 100%, and that's probably due to rounding. So a lot of times, if you round perfectly, it will add exactly to 100%, but don't be surprised that once in a while it could be 99.9 or 100.01. It'll be very close to 100%. So how do we find percent composition, also known as mass percent? The first thing you're going to do is you're going to find the molar mass, which we had seen in a previous video. And then once the molar mass is found, then we're going to use the formula below to obtain the percent composition of each element. Now, the molar mass will be the denominator of the formula below. Once you find the molar mass, that would be what is considered to be the whole. And then the part will be the mass of each individual element over the total, which is the whole, times 100. So, let's say we wanted to find calcium chloride, the percent composition of calcium chloride. Well, first, remember calcium is Ca, it's +2 charge. Chloride comes from chlorine, which is -1. So when you follow the crisscross method, you're going to see you get CaCl2. Now, the first step is to find the molar mass of calcium chloride. So remember, you list your elements, and then you put how many you have of each. We have 1 calcium in this formula, and we have 2 chlorines. Now, you go to the periodic table, and you'll notice the atomic mass of calcium is 40.08. Chlorine is 35.45. So once you get the atomic masses, let's write that down here, 40.08. We got 35.45. And if you remember the molar mass, you basically multiply across. So we got a 40.08 for calcium chloride, for calcium. And then 35.45 times 2 rounds to 70.9. And then let's add that up. So 70.9 plus the 40.08 of the calcium, you get a total of 110.98 grams per mole. Now, this is going to be the total. So there are 2 elements here, so I'm going to give you 2 answers. So to find the percentage of calcium, you do the part of calcium. You're going to look at this part right over here. So it's the part of calcium, which is 40.08, over the total of calcium. Now, the units are going to end up canceling. I'm going to go ahead and show you here, but these are the units. When you find percentages, you're going to see that there are no units. They're going to completely cancel out. So 40.08 divided by 110.98, which is the total. And then don't forget to multiply by 100 when you do this. You're going to get that the percentage of calcium is going to be 36.11%. Okay, so there's our calcium. All right, now let me make some space over here. And, whoops, let me go back. Let me put these numbers here so we can see them clearly. Now, what we're going to do is let's find the percentage of chlorine. So it's going to be the same thing. We're going to find the part of chlorine is 70.9. I'll save some room here. And you know it's going to be grams per mole. Units will eventually cancel. Divided by 110.98. And again, times 100. To make it a percent. So 70.9, which is the total of chlorine, divided by the 110.98, which is the total of the compound, and then times 100, you're going to get 63.89. Now I rounded that part there at the end, 63.89%. And these two, if you do add them up, they end up adding exactly to 100%. Sometimes it might be 99.9 or 100.01. But here is the percentage of each element in calcium chloride. Okay, and if you look here, here's what we did as a summary. We multiplied the two calciums by the molar mass. We got 70.90. Then the one calcium was 40.08. We added them to get the total here. Okay. And here they're showing you the two percentages that we obtained, which we did accurately. Okay, now again, they rounded it to 63.88. There was a 5 behind that 8. That's why I rounded it to 63.89. Okay, so this is the solution from the book. All right, let's do another here. Let's find the mass percent. Now this time they're only asking us to find chlorine. Okay, if they ask you for a specific element, then you don't need to do it for every single one. The previous example, there were 2 elements, so I gave you 2 answers. So again, Freon 114 is composed of carbon, chlorine, and fluorine. And as you can see, there's 2 carbons in the formula. There are 4 chlorines and 2 fluorines. Okay, so then we got to go to the periodic table to find the molar masses. So we're going to get our carbon here at 12.01. Okay, our fluorine's rounded to 19, and our chlorine is down here at 35.45. So those are the molar masses that we're going to be using in just a moment. So we're going to go back here, and we're going to go ahead and set this up. So we said carbon was 12.01 from the periodic table. Chlorine is 35.45. And the fluorine is 19. Okay, so we're going to go ahead and set that up. And then we got 2 times 12.01. That's going to be 24.02. Okay, and then we got to multiply 4 times 35.45. And that's going to give us 141.8. That's a 4 over here. Okay, and then 2 times the 19 for fluorine, that's going to give us 38. And then what we're going to do is let's go ahead and add these guys up. So we're going to go 24.02 plus the 141.8 plus the 38 for the fluorines. And we're going to get a molar mass of 203.82 grams per mole. Now in this problem, they only want the percent composition of chlorine. So the last step is to get the part of chlorine, okay, which is 141.8, over the total. Remember, that's always going to be the total, which is going to be, let me fix this here. Hang on a second. There we go. And that's going to be 203.82. Again, technically, the units are grams per mole for each of them. They're going to end up canceling. Okay, so we got 141.8. We're going to go ahead and divide that by 203.82, and we're going to end up, and don't forget, always multiply by 100 to make this a percent. You're going to end up getting 69.57% as our percentage of chlorine. Okay, had we done the other elements, it would have been done the same way. For instance, carbon would have been 24.02 over the total, which is 203.82 times 100, and fluorine would have been 38 over the total times 100. Okay? And if you look here, here's the solution of this one. Notice we did multiply the 4 chlorines by 35.45. We got that. There's a Cl here, typo. That's Cl4. That was the 4 chlorines. We have the 2 carbons that we multiplied. We got 24.02 over here. Here are the 4 chlorines. Here are the 2 fluorines. Okay, they rounded it. We actually used the actual number. And our number was 69.57. They got 69.58. I would tell you just to keep using 2 decimals deep. So, you know, don't round. Just go ahead and if you do round it to the hundredths place, they rounded it to the tenths here, but notice how their answer is still to the hundredths. Okay, but this is just to check. Let's try one more. So this one is acetic acid. Okay, it's an active ingredient in vinegar. It's a weak acid. They want us to find the mass percent composition of oxygen in the acetic acid. So we're going to focus on the oxygen. Now, as always, the first thing is to find the molar mass, which is the total of acetic acid. Now, we got H, C, and O. Now, if you look carefully, we can combine the H's. There's one in the beginning and 3 more, so there's actually a total of 4 H's. There's only 2 carbons, and there's 2 oxygens. Okay? So then the next thing we're going to do is we go to the periodic table. 1.01 will be your H. Your carbon is 12.01. Your oxygen is 16. Those are the atomic masses. Let's go back and fill that in. So we got 1.01 for hydrogen, 12.01 for carbon, and oxygen is 16. And then what we're going to do is we're going to go ahead and multiply this thing. So we get 4.04 for the hydrogens. Then here we get 24.02 for the carbons. 16 times 2 is 32. And then we're going to go ahead and add. So it's going to be 4.04 plus 24.02 plus 32. We're going to get a total here of 60.06 grams per mole. Now, they wanted us here to find the percentage of oxygen. So the last step is to do the part of oxygen, which is 32, over the total. Again, the units are going to end up, let me fix that. The units are going to end up canceling anyways, okay? And then don't forget to put times 100. So let's go 32 divided by 60.06, okay? And then times 100, of course. And we're going to go ahead and we're going to get a percentage of oxygen equal to 53.28%. That's going to be our percentage of oxygen. Okay, and that's what the question was asking. If you look over here we can check our answer. They got 53.28%, just like we did. Okay, so this is how you find percent composition, also known as mass percent. You're going to first need to find the molar mass so you can get the denominator, which is the total. And then you simply do part over total, multiply by 100, and that's how you'll convert it into a percent. Okay?